Hello and welcome to today's webinar. My name is Tyler Reid and I am the Manufacturing Application Manager here at GoEngineer. Today's topic is the CAMWorks Sync Manager. So the CAMWorks Sync Manager, what is it? It's a module for CAMWorks that allows us to program twin turret lathes. Twin turret lathes, normally a front and a rear turret, like the image that you see up there, are becoming more popular today. And a lot of times these lathes have live tooling or just some regular turn tools on them. But programming them adds some extra steps to the process and extra codes that we need in the G code in order for them to function correctly. If you don't have those weight codes, we'll see what happens later on in the webinar here, but it's incredibly important that we have these weight codes. Most CAM programs don't have the ability to add or program or control these weight codes built in, but CAMWorks does. So we're going to get a short preview of what it is, kind of how it works. It's a very simple tool. It doesn't take a long time to discuss, so this should run about 15-20 minutes on this webinar. The CAMWorks Sync Manager is used for both turn operations and mill turn operations. So if you're an existing CAMWorks user, you kind of know what those mean. And if you're new to CAMWorks, a turn operation is just a regular lathe operation. And a mill turn operation would be a live tooling situation. Again, looking at that image there, we are seeing two mill turn operations there. They're both end mills, and the spindle, the C axis is kind of locked in position, and we're doing some milling there. CAMWorks Sync Manager can handle both. It is a separate CAMWorks module, so it needs to be enabled in your license file for you to be able to kind of poke around and look at it. And it's really only necessary for CAMWorks users who have twin turret lathes. So again, a front or a rear turret that need to be synchronized. It is compatible with the CAMWorks Virtual Machine Simulator. I'm going to show this at the end of this webinar here. After we program our part, we can load that G code up into our CAMWorks Virtual Machine Simulator and simulate the true G code in the full machine environment that would show not only the tools and the holders, but also the turrets and the chucks and show our full length of travel and whatnot. So we're going to jump into SOLIDWORKS here. I went ahead and programmed this part ahead of time, just to save some time on this webinar here. If you're interested in learning how to program a part like this that uses front and rear turrets and also a main spindle and a sub spindle, then go ahead and check out my CAMWorks 101 webinar that I did a while back, and that shows step-by-step how to go through that process. This webinar could be sort of a follow-up here that shows how to sync the turrets. Okay, so we're going to step through and talk about how I've programmed this part and what is left over to program. So it's a fairly complex part. It has both milling and turn features, and we will be programming this from the main spindle and the sub spindle. Possibly the easiest way to discuss what I've done is go through the machine simulation. So if we simulate this by operation, we do a couple facing operations. We do an OD turn operation, a roughing, and then a finish pass. Some drilling and boring on the center, the ID there. So we create an outer shape, and then we come in and we mill the flats in the Z direction. Okay, and then we're going to start programming these bolt patterns, these mounting surfaces all around the part. And they're done one by one in this simulator. And these faces here and these bolt patterns are where we have an opportunity to make our program more efficient. Okay, because we're going to be able to do those simultaneously rather than one at a time by taking advantage of the front and rear turrets. So just continuing on with this simulation, there was a transfer from the main spindle to the subspindle. That's programmed directly into the software. We have templates set up in our post processors to allow you to say, at this point, we want to do a transfer, or we want to come in with the subspindle and just grab onto the part and hold it with both spindles. We can do pretty much anything you need to do on the subspindle. In this case, it just transferred and pulled it back. And now there's some grooves that are being cut from this side and some ID boring operations as well. The last groove there and the finish. So at this point, this part is essentially programmed to its full. We can do a check here. You're looking at a color coding of the part as we've cut it versus the part as it's been modeled in SOLIDWORKS. Green indicates that we've cut it to size. If there was some blue or some red colors in here, that would indicate that we've undercut or overcut the part. So at this point, we're good. The problem is if we were to post out the code right now, we would get code that runs the front turret and the rear turret kind of simultaneously to start the program. So here's a step through, and we can see now visually what was being cut with the front turret, which if we are looking at the machine, this tool on the bottom, right here, would be the front turret nearest to the operator, and the tool on the top would be the rear turret farthest from the operator. If I were to program code, when I have front and rear turrets, it actually generates two text files. We load up both text files, and those text files are started on the machine control at the exact same time, and you end up with a result that looks like this. It would essentially crash the machine. I'm going to turn down the speed a little bit, and we'll go operation by operation again. Notice that it is cutting the OD of the part at the same time as it's drilling some of the surfaces on the other side. And that's not what we want. So this is where the Sync Manager comes into play. We can say, hold off, instead of starting programs right at the same time, wait until a certain operation is finished before you bring in the front turret, and then machine these two operations at the same time. And then once those two operations finish, go on to the next ones. So we can set operations to machine together. It's incredibly important for, one, this machine to work properly, but two, to really take advantage of the capabilities of our twin turret machine and machine parts much quicker. In this particular example here, we have cycle times that if you were to run them successfully, just one after the other, cycle time's about 35 minutes. Versus once we start syncing them up, it narrows down to, we'll see the value here. So the Sync Manager, it's activated inside CAMWorks. I have this button up at the top of my toolbar. Your button would look a little bit different just because I've adjusted my toolbar a bit, but it's still named the CAMWorks Sync Manager. And the menu looks something like this. We have two columns. Column on the left are operations being cut with the rear turret, and operations on the right are being cut with the front turret. We also have an indication as to what spindle each operation is being cut with. So that's this very first icon in the column. You can see these are being cut with the main spindle, and then the sub spindle down here at the bottom. These operations here. This is also controlling the order that these are being cut. Now, I pretty much have the order set up, but I can drag and drop within this menu, and it will update my CAMWorks feature tree. So this menu is actually a little bit more clear, I believe, than the CAMWorks feature tree. We can drag and drop here, no problem. We can also drag operations between columns. So I can say this rough groove, I can pull this over and drop it onto the front turret. So I don't actually have to go into the operation parameters and make that adjustment in the tool tab. I can just drag and drop here. If I were to double click on one of these operations, it does take me into the operations parameters. So again, it's a little bit of a shortcut there. Okay, so what you're seeing here are the front turrets and the rear turrets, and they're essentially going to post out in two separate files. in this order and at the same time. So you can think of these columns as having these two highlighted operations are going to post at the same time. Okay, so what we can do is add wait codes and kind of sync up these operations. There's two different ways to add these wait codes. One is called sequential, and it just looks like this. Each of these pink bars is a wait code, and you can see they're numbered 101 through 135. And notice that the operations on my front turret moved down until these operations were finished here. So this is the order that it's going to post out. Sequential just means don't sync up the operations, just one operation at a time, and then once that finishes, it goes on to the next, and then the next, and then the next. So it's not a fully optimized program, but it's not going to crash like the original one was going to crash. So that is a plus. If we want to look at the time that it would take to program this, we can go over to the Time View tab, and we can see a timeline here showing at what point is each operation going to start and finish. And we can see the utilization of our main spindle, which is the top area, and the sub spindle here. It looks like the overall time is right around 35 minutes. So coming back to the Sync Manager, I can also do a user defined, which is more of a manual placement of the wait codes. So using these buttons up here in the top right, I can delete all existing wait codes, and now we get something that looks similar to what we had. And I can start pairing up operations to be run simultaneously. So going back to looking at our part where we had these mounting holes, I want to be able to machine opposing faces simultaneously. So I can grab those operations, and in this case, it's contour mill 15 and contour mill 23. I highlight both, and I can insert wait codes before and after. So what that causes CAMWorks to do when it comes time to post is it will post these first operations up to the highlighted portion here. And then at that point, it will see the 101 code in each of the programs and know, okay, now I should start at the 101 position. And it will post these two at the same time. Going on to the next step, I can add a wait code after these and these as well. And I'm just going to go down the list here. And this ensures that they are all synced up. If I didn't add wait codes after each operation and just relied on that first initial one, depending on the operations on the front and the rear, if they're not the same cycle time, one could get ahead of the other. But by doing wait codes after each operation, I can ensure that they will never kind of run away from each other. Okay, now at this point, on the rear turret, I have my sub-spindle transfer. What I really want to do is kind of skip that, let it transfer, and then come back down to the grooving tools and cut both grooves at the same time. Remember, there was two grooves on the other side. So again, I'm going to highlight those two, add wait codes above and below. And I don't need to do anything at this point with this last one on the front turret here. So now we should have a much more efficient machine program here. And we can see if we come over to the time view now, our cycle time is down to about 28 minutes. Okay, so I'm not good at math, so I'm just going to go ahead and say it's 28/35 the time of the original program. Okay. I'm going to go ahead and select OK. It will regenerate the toolpath. And now when we do a step through, whereas before, the front turret operations were starting at the exact same time as the rear, we can see that's no longer the case. So if I go by operation, it's going to do the OD cuts, those ID features, the boring, cut the flats, again from the rear turret. And now, because of those wait codes, it says, okay, I realize I'm going to be cutting these both at the same time. And these are all synced up. So this is a much better way to program this part. We can also be a little bit more aggressive in our feeds and speeds at this point because since we're cutting from both directions, in this case, we'll have symmetric forces, so we can be a little bit more aggressive in our programming as well. Now we see the transfer. On that side, we were syncing up live tooling operations, mill turn operations. On this side, we synced up some grooving operations. And that's that. So this sync manager, this is really all there is to it. It's just some adjusting of the positions and adding our weight codes. There are some other options that we do have. We have control over what the weight codes look like and where they will be placed in the G code, but we're not too concerned about those details at this point here. At any time, I can delete the weight codes that I have or override them, no problem. So when it comes time to post out this code, I post it out the same way as before. And what you'll notice in the folder, it will create several files. It creates a front and a rear program, and those are the two files that we have to load up on our machine control. So if we look at each one of those, realize this may be difficult to see on your screen. You can see our M101 codes in there. Now, when it comes time to transfer that program to the machine simulator, you can load up those files, which you see here on here's the rear turret and the front turret. I loaded these up in the standalone version of the machine simulator, which means I can open up the program on demand. The non-standalone version has to be launched from CAMWorks. When you launch that version from CAMWorks, it loads up the tools for you and your stock information as well. And that's kind of what you see here. If you haven't seen this machine simulator, I'll kind of back up. Our entire machine is built. We have the front turret and the rear turret. I can change the view here and just show you guys the tools that were loaded. So you can see we have a full turret on the rear and, just a few tools on the front turret. As I program this part, it's actually going to read the G code and simulate the G code that you see over here on the left and on the right. So I'll kind of let that run. I can pause it at any point. I can change the view back to the machine view. The nice thing about this is we can do all of our gouge checking and collision checking on our tools for the entire machine environment, which is difficult to do or essentially impossible to do in the standalone CAMWorks simulation. So there's our OD cuts. The ID operations, the cutting of the flats, and then there is what we were after, is the syncing of the tools. At this point, you can see the subspindle come and grab the part, and it comes and finishes off that part. So you would do a quick check-in here before you actually take it to your machine. There's some real benefit there, especially with the complexity of the tool holders. This can accommodate gang tooling if you have that, and just a lot less for the programmer and the operator to kind of worry about on expensive machines like this. So that's about it. I promised 15-20 minutes on this webinar, and for once I actually adhered to that. The CAMWorks Sync Manager, it's an essential tool for any CAMWorks user using the twin turret lathe. Otherwise, you have to go through and you program out those two G-code files, and the operator, or again, the programmer, has to go in and manually add those weight codes. There's really no way around it. So to be able to do that inside CAMWorks with just a pick and play, something that you can really pay attention to what you're doing and keep track of all of the steps is essential. So if you have any more questions about the CAMWorks Sync Manager, you can go ahead and shoot me an email. You can contact me through there or through our YouTube page. And thank you for joining this Lunchtime CAMWorks webinar session. If you have any recommendations for further sessions, again, let me know. Totally open to some ideas there. So thank you guys for joining, and I'll catch you later.